My name is Patrick Mihalichuk. To fully understand the concept of what an isotope is, you must identify the neutral structure of an atom. An atom is composed of three basic particles. There are protons, neutrons, and electrons. Protons and neutrons are located at the very center of an atom. I'll represent neutrons by a shaded circle and protons by an empty one. But electrons are spinning around these neutrons and protons all the time. Usually, there are the same number of electrons as the number of protons. I'll represent electrons by smaller shaded circles. Protons have a positive charge of 1. Electrons have a negative charge of 1. Neutrons have no charge at all. They're just neutral. An atom will stay stable, assuming there is an equal amount of protons and electrons. The neutrons and protons have an equal mass of 1 each. So this will have a mass of 1 and this will also have a mass of 1. When they are added, they give out the atomic mass of the element. Now, electrons have such a small mass that they're negligible. Let's check out isotopes. An isotope is a different version of any element. It can have more or less neutrons than normal. To refer to an isotope, you write it like this. X equals the chemical symbol. Y equals the atomic mass. This is also equal to the amount of neutrons and protons added up together in the nucleus. Z equals the atomic number. Let's look at hydrogen. It has 1 proton and it has a single electron orbiting around it. But what if I threw in a neutron there? This would now become deuterium. It's called deuterium, like double, like 2, because there are 2 particles in the nucleus. And there's 1 more neutron than normal. Now what if I would throw in another neutron and it would get sucked into that nucleus there? This would now become something called a tritium isotope. Tri like triple, like 3, because there are 3 particles in the nucleus. Now, how would we write this in isotope format? A deuterium hydrogen atom would be written out like this. Hydrogen, and the Z for the atomic number is just 1. Now this hydrogen tritium is written out almost the same, except it's a 3 up here, since there are 3 particles in the nucleus with an atomic mass of 3. I'm just going to talk about beta decay for a second. What is beta decay? Well, heavier items tend to require more neutrons than protons. Lighter items require more protons than neutrons. If an atom doesn't follow this rule, they can become unstable. And when it becomes unstable, the nucleus decays. So say if you have a neutron. The neutron decays by spitting out radiation in the form of particles or electromagnetic waves. This is pretty much one electron comes out of that. It also gets turned into a proton. And that's what beta decay is. Say if you have a proton here, it goes through the same process, except it actually eliminates one of the electrons away from the atom, and it gets turned into a neutron. That's beta decay. When beta decay does happen, in hydrogen tritium's case, since this is unstable, one of these neutrons will become a proton, because hydrogen cannot just kick out a neutron. It's too strongly held in there into that proton. So once that neutron becomes a proton, also lets off an electron, which goes spinning into orbit. So this is now an isotope of helium missing one of its neutrons. And let's look at the other end of the stick. Too many protons. Beryllium is supposed to have 4 protons and 5 neutrons. But in this case, in this isotope, it is missing 2 of its neutrons, leaving it with only 3. And there are 4 electrons spinning around it. In beryllium's case now, it is unstable. It has 3 neutrons instead of 5. And a proton now has to turn into a neutron. So that's what will happen. When it turns into a neutron, it also eliminates one of its electrons spinning around, orbiting it. And that looks a lot like lithium. Lithium has 3 protons, and it also has 4 neutrons. So it's now stable. And I hope you've learned the answer to the question, what is an isotope? And just as a refresher, it's basically a different version of any element in the periodic table. And I hope you understood the concept of an isotope and taken an interest to it, because I sure did. This is Patrick saying bye. And thanks for watching. Gonna go watch some SpongeBob.